I got online and I figured out ways to do everything we needed to do without going inside of buildings. And at the same time, all of the stores around here figured out how to do what we call curbside pickup. So the first week, there were 2 grocery stores, sort of high-end grocery stores, each very close to me, that had a mechanism where you could go online, order, set a slot when you were going to come pick it up, go pick it up, call in, and they bring it out to your car. So that's what 2 stores were doing, and something like 1 or 2% of their volume was that. But they did have a way to go online and do it. They had their inventory online and all of that. And of course, it got flooded by me and lots of other people immediately. And because it got flooded immediately, it got overwhelmed. And the slots, when I first started, after a while, you couldn't get a slot for 2 weeks to pick up any groceries. Well, that got fixed, but it took, for one store, it took about 2 weeks. For the other store, it took longer because they were dealing with a vendor who, had plenty of other things to do. But within it took almost 3 weeks, every single retail outlet around here had the same mechanism. Go online, order your stuff, pay for it, drive up to the store, call in with your cell phone, and they come and put it in your car. And I have a minivan. I push a button and the door opens and I put it in, I push a button and it closes. That's how we get everything except one place we have delivery because they don't have curbside pickup, but they have delivery, and then we do some online shopping that gets delivered through the package delivery services. But mostly every store around here, even our local shopping center, they've got a place where you can drive up and every store in there can bring their stuff out to you through that way. And the thing is, if you were in their software group, right? If you were their technology people, or if you were there, you would have been the one that would be on the stick to make this work. And now imagine the team that has a week to put up a curbside pickup site. And we're talking inventory, we're talking staffing, we're talking how, who's going to do the shopping, how are you going to store the food so that it doesn't spoil, where are you going to store it, how are you going to notify when you're at the store. And there's a few different schemes, but they're basically the ones that did it fastest did it really, really simple. Our favorite little restaurant, you called them up, you talked to them on the phone, you gave them your credit card number, you drove over at the time you agreed to, and you called inside on the cell phone. It didn't take them anything to do that because they had their menu online already, right? But pretty much, I'm guessing that if you were on a software team, you were on a team that was putting this together, you had software people, you had inventory people, you had procurement people, you had staffing because you had to figure out procedures for doing this, and you had a week, okay? And that team had 1 week to go from nothing there to something stood up and people using it. And they didn't use any process other than you're gonna know when it's working and make it happen. And the same thing, I give a talk at the University of Wisconsin online, maybe 6 weeks in. It was just after we had the riots over the race issues here. And we had been at the University of Wisconsin in 1968 when the exact same thing happened, and Tom was a photographer then, and we had pictures. So I gave a talk about that. I gave some pictures of it and stuff. And at the beginning of that conference, their CIO came online, and she spent 10 minutes talking about what it took and thanking everybody because this was for their internal software people, and talking about, so she knew that she was paying attention, what they had to do to get every professor teaching online and every student learning online in 3 days. And they did. And the professors had never used a tool. There weren't internet access points. They did everything necessary to get the stuff moved, and they did it in 3 days. And you can believe that they didn't worry too much. They quickly put hit teams together to deal with one problem after another problem after another problem. And they just knew when it was working, And if you think how fast that went, we could do anything that fast if we choose to. but we have to have whole teams. We can't have software teams that do what some intermediary person tells them after this team decides what they should do. That's too slow. And besides, half of the problem was a technical problem, only half. But if you don't have technical people on the team that's going to solve a technical problem, and if you don't have inventory people on the team that's going to solve the inventory problem, and it's the same team together, it's not going to happen in 3 days or 4 days or 2 weeks or whatever you have. And so if you think about that, you think about this is how we have to form teams so that they can very rapidly talk to each other, understand the problem, know when it's solved.
And I wonder, the store near you that took longer to get up and running, do you think they built something and then they
no, I can tell you what happened.
The staff involved?
Because they used to be one of my favorite stores, and I actually don't shop there anymore. But I said, well, how come it's taking so long well, what you couldn't do is you couldn't change your order once you put it in. And it took him like 3 weeks to fix that. And I couldn't believe it. And they says, well, the company that we contract our software to isn't available yet. That's why it took so long. That was the response I got. And I'm thinking, the company you contract your software to, huh? No wonder you're having trouble.
I wonder how many of especially the larger conglomerates, just hadn't been asking how stores are doing stocking, how to.
Well, we're really not talking about conglomerates until you get to like Target.
Yeah.
Okay. We're talking about local grocery stores.
Okay.
We're talking about, and Home Depot, because those are big chains. So there you have a conglomerate. Mm-hmm. And in fact, Target and Home Depot both got apps, and it took them six to 8 weeks to do curbside pickup. And when they got the apps, they were way too fancy because the app had a way where you, once it was ready, it notified you, and then you got into the app and you said, I'm on my way. And then when you got there, you pushed another button that says, here I am. And then it put up a barcode so they could check it was you, you know. So it was really fancy, but it didn't work. For example, so we're supposed to use the Home Depot app to tell them we're in the parking lot, and there's no signal where they choose to tell you to park. No mobile signal, nothing. And so you're sitting there saying, I can't even make a phone call because they don't have a number up here. They're expecting my app to work and there's no signal. And so if you do things more simply and then add on features as time goes on, but you make sure that the very first thing you do is really simple and actually works, then the local grocery store that had 2 weeks out, they fixed that so fast. I'm sure they had local staff and they got on top of it just like that. And they had, there was a time in there, and they did a lot of asking for feedback. There's a time in there when we couldn't get chocolate milk. You know, and I buy a small thing of chocolate milk like every week or so. And I had a way to send in and say, what's wrong? And it turns out that the vendor had changed the logo on it to a different branding. And therefore the UPC code wasn't right. And so it fell out of their inventory and they didn't get the new one in. And after about two conversations with the person that I'm contacting with, that person was able to immediately go over to the group that figure out that there was a changed UPC code, go over to the group that loaded it onto the website and get it fixed, like in a day. That's something that would take a big company like weeks, because it was an oversight, because if you weren't in the store, you didn't realize that it's not on your website anymore. But getting the inventory accurate on the website, both when it's out of stock and when it's in stock, is really tricky. And some of them do it way better than others. It's not a simple problem to do curbside pickup. And it's very much a people problem and a process problem and a technical problem. And if you don't have all three on the team, there's no way you can do it as fast as you need to. And I would say an awful lot of software is like that. We could do way better if we would just put small, complete teams together and had them at a well-defined problem where they can tell whether or not they've got it right, and they can fix it if they can't. And we don't do that. But when if you think about the coronavirus response in your area and the things that went really well, that had technology behind them, you can bet that that's the kind of teams that were working on it.
Definitely all the places that did very well in London were mom and pop shops. Were the small
Ocado.
They crashed. They had a lot of issues, and it's hard to get Ocado.
They crashed, but how fast did they get back up?
It's true, but they couldn't accept.
Oh, how fast did they? I'm curious, because I spent, the last time I was in London, I was out there for 3 days. And so I know those guys. So how I know that they crashed, I was just curious, how fast did it take them to get back on their feet?
And you want a member? Because I could never get a membership. I still can't.
Oh,
You're
not back on their feet then.
They're still, they're not, there's evidently everyone was booking at like 3 a.m. People were setting their alarms, and
oh
I
yeah,
don't know, it seems like a great organization, but I don't know anybody new members.
Well, that was the biggest problem here too. Anybody that had a system in place, it was completely flooded instantly.
Yeah.
And the store that I went to, you know, as I said, all of a sudden things went out to 2 weeks and 3 weeks, and then they fixed it in about a week and a half. They fixed it. And fixing it was way more than fixing the technology. Fixing it mainly meant to have the staff and the staging mechanisms and the processes and the parking spots to be able to handle way more people.
Fantastic, but that's good. Staff is a good problem to have, especially in a
recession. The other interesting thing that Ocado doesn't have going for it, that our local grocery store does, is there's zero change in the supply chain. If you go to your local store, it doesn't matter if you go inside or you do curbside pickup, they just have a few staffers. But everything coming into the store is coming through the exact same supply chain as it came through before. And therefore, you don't have supply chain problems. And almost everything that has gone wrong, you know, that all the shortages you've seen, they're all supply chain problems because of overwhelmed supply chains. But if you're going into your local store, the supply chain isn't going to really be overwhelmed. So because nothing changes coming into the store. You're using exactly the same supply chain. And that's why that works so well. You have to have a car though, you know, and in London you may not, but in a suburb, everybody does.
For sure, yeah. That's a whole other supply chain issue here, because pretty much all the quick testing sites are drive-in and only half of London own cars. So it's very elitist decision to allow only the rest of the people have to go through the mail, which takes about a week longer to get that test versus about 18 hours till results. So it says a lot. I think if everyone's voted, I think we should hit the merge topics and look at the questions y'all have for Mary.
Great.
Hold on, start discussion. Oh, it's very clear, the top two. So the first one, what is your view on AI and the future of work? If anyone who brought up that topic wants to give a little more information, please do.
Well, we got some views. You want to start with that one, Tom?
Go for it.
Yeah, well, go ahead. That's a good topic. Come over closer.
AI depends on training data. Training data became obsolete in April in many, many applications. So AI suddenly became useless in many cases. Training data is often biased. It's very difficult to avoid bias in the training data for your AI. There are all kinds of bias. The intelligence that you really need is to be able to see, detect, and repair the biases that are so deeply embedded in the information that we choose to gather? Did we choose to pay attention to? There's a lot of potential, but there's also a very high risk in the applications of AI.
So the way Tom puts it, I think, I knew he wanted to answer that question, by the way, is AI is just another higher level language. Gone through many, many generations of higher level languages. This is another level of abstraction, but the need for intelligence just goes to a different level. There's never been, I've listened for 50 years about how work was going to be knocked out by the next generation of technology. Hasn't happened yet. And I don't see it happening in the future. That doesn't mean it's going to be the same. It means it's going to be different. And it also may mean that some people that have been spent their entire life with one particular way of doing things might not be the kind of background that's needed for the next generation of workers. Okay. But from the time in the UK when weaving went to factory mills instead of in the home, and there were riots because people lost their weaving jobs, when machines came into the factory instead of the hand looms, and they thought there would be no more work. And then you say, well, the coal mines are going to close. Well, okay, but I'll bet you there are going to be lots of jobs in the energy industries that emerge from that. I've never seen work disappear. It's just changed. So what you have is a group of people that have been very successful in an area, and it's really difficult because they've done it for too long, or they're too old, or they don't want to change or whatever, to move into the next era. And then there's those who will. But if you look at, take the people who are the young generation, our grandchildren, we have 2 grandchildren, one just out of college and graduate school, and one going to graduate this year, next year, forget which year, in June. And they don't care that the work is different. They'll pick up whatever is available and they'll get good at it. And if the people who are doing stuff can figure out how to move into being useful in whatever the new work is, smart people are always going to be necessary, especially in software. We're not gonna outgrow our need for smart people to figure out today's level of complexity. And that doesn't mean it's going to be the same. And we keep adding stuff, but this idea that programming is obsolete is crazy. And it's also true that as we pick up jobs, what we're trying to do with many kinds of automation, because I've been in the automation world for decades, is we're trying to get rid of the routine work that doesn't require thinking so that we can have the next level. Like, let's take the SRE job, system SRE, site reliability engineer. The current world of people who used to be the technicians that ran the computer center. Remember those, what do you call them? Sysadmins? Remember that job? Very manual job, lots and lots of detailed tasks that you had to do. Today, at least 6 months ago or 9 months ago, the SRE job was the highest paying software technical job in the United States. And it was the same job, only it was automated instead of do it manually. And the whole game was to automate everything that was a manual task that was considered like toil. That's Google's word. Automate toil and spend at least half of your time doing creative stuff that makes things better. And that's how work goes with any kind of technology step forward and automation. And I don't see why that's going to stop. It just is that there is a hump where people who have had this kind of job for a long time and don't see a future in it, don't have the background, the interest, the physical, okay, whatever, to change, then it's hard on that particular group. But it's not going to wipe out jobs in the whole universe. It's going to just change them and hopefully make them where you can spend more time thinking and less time, just doing repetitive tasks.
Absolutely. I want to know more about the training data comment you made, Tom. So you said that like up until March, training data, where did that training information go? I was confused by that.
Well, for example, retail buying patterns. What people bought, how they bought it, shifted completely, very rapidly. So any inventory forecasting that you did, sales forecasting, staffing forecasting that you did based on 2019 behavior of the market no longer applied. And there was no data available to feed into your AI engines that would help you make decisions when it came to March and April, or May, or June, or July. Now, maybe in November, we're starting to get enough data, but things are still changing quickly. The behavior of the population in the US, the behavior of the population in Europe, different phases in our peaks, but it's producing a vastly different context that the older training data no longer applies to.
So what shortages have you had? One of the interesting shortages we had was flour. Right? Flour. I don't know if you had trouble with flour, yeast, that sort of stuff. Well, yeast you can deal with if you can do sourdough. I love to cook, so I actually, the 10 days between when we came into our house and when we got home, we were in New York City and we had visited our son in Washington, D.C., and he was stockpiling food then. I thought, wow, that's interesting. I wonder why. I get that he thinks something bad is. So we went to our local Costco, which is the big bulk place, and we stocked up on stuff, including I got a 12-pound bag of flour, and it was lucky I did because pretty soon you couldn't get flour. Well, it wasn't that there wasn't enough wheat. There was plenty of wheat in the grain silos. It wasn't that there were not enough grain mills, because old grain mills can be repurposed really fast. Why we couldn't get flour is because half of the flour went in 50-pound bags to bakeries and the other half went in 5-pound, maybe 10-pound bags to retail outlets. And the bakeries were all closed, and the bakeries were no longer buying flour. And so you had to be able to package stuff in 5-pound bags and get it to stores. They didn't have the packaging capacity in the plant or the bags to package and retail stuff. And the demand for that went like immediately the other way. No AI system in the world that predicted inventory stocking would have told them that they had better completely change and develop a mechanism to package flour fast in much smaller quantities.
There's also the question of how is your facial recognition artificial intelligence dealing with face masks?
Or people of color.
Yeah, well, but that was always there, but all of a sudden, everybody in public wears a face mask. At least I hope.
Hopefully not.
But all of a sudden, that AI doesn't work anymore.
Right?
Crazy.
So that's a good one. Let's go to the next question.
Absolutely. People are
anybody wants to ask more on this one?
Anybody else? The next question is, I would like to hear more about Mary's ideas on transforming workforces development teams. JavaScript is everywhere, and now boot camps offer 0 to hero in few months. How will that transform software development teams? And I just want to add, it unequivocally, as long as you can hire boot camps, that's how you increase diversity on your team. So who came up with, whose topic was that?
I want to know who asked that question, because I don't quite understand it. So,
well, the thing, can you hear me?
Yeah.
The thing is that when you were studying at that time mathematics, it took you, I think, 7 years to get a master's degree. It took me 5 years to get my master's degree to get into into software development. Now people get into software development after just a few months of bootcamp studying. How will this change the future of software teams, software development teams?
So actually, I never took a class in software development because I They didn't actually have them at that point in time. I started just when the very first early computer science courses were available. But what I learned in my years in getting a master's degree was I learned another level of how to think about things. If you get a degree in engineering, the main thing you're learning is how to solve problems, how to identify problems, how to solve them, how to be responsible for the results. If you're in an engineering program here and you get an engineering degree and then you get certified, you become personally responsible for the safety of the systems that you put out there. And so you're not only learning how to solve problems, you are learning how to be careful and accept personal responsibility for safety. I have a potential future son-in-law, boyfriend of my daughter, granddaughter, so grandson-in-law, I guess, who became an engineer, and he says, I'm nervous about taking the engineering exam because once I become a professional engineer, I get personal responsibility for what I'm doing. And he was designing solar systems and stuff like that. I'm sure he's not going to be designing the same thing for the next 30 years, but he will have learned how to ask the right questions, how to frame problems, how to attack problems, how to think about safety, how to make sure that stuff doesn't kill people. It's those kinds of things that you learn if you're in a good program. If all you're learning is a language or a current pattern or something like that, then you're not learning how to think. And I think that the advanced degrees that people get, or even the college degrees that people get, what they're doing is teaching people how to think. Now, you can learn how to think as a junior apprentice. I have to say, most of the engineering principles I learned was when I was in the engineering department at 3M, which I spent like 4 years in. And those senior engineers, they knew how to do engineering. They knew how to think. And being in that engineering department with these people who've been designing process control systems that drove really big equipment for decades before there were computers, they really knew how to tackle problems and how to engage customers and stuff like that. So I think that learning and degrees give you way more than a narrow sort of one skill, or they're the wrong degree.
I would suggest that you really don't need to worry too much about it. The people who get into learning a language through a boot camp are probably equivalent to those who learn how to do things with a spreadsheet. Now, there are huge needs for very sophisticated models, very sophisticated analysis, the data science and so forth, which a spreadsheet will never do. But there's also a very large market, a very large need, very big benefits to be had from effective use of spreadsheets. If you do it with JavaScript rather than spreadsheets, all right. If you're doing a website, an interactive website, you probably don't need high levels of abstract thinking and modeling. And people that can do things at a less sophisticated set of applications can probably do just as well. Marketing, sales, all sorts of areas have a rapidly growing need, but not necessarily a need for the level of sophistication that people with more advanced training, more capable tool sets can deal with. So I think it's more of a broadening into a ubiquity of use of computing rather than a dilution of the value of the more sophisticated thinking that we're used to thinking about software.
That brings up something I want to make a comment on, even though somebody didn't ask, and that is one of the things that has bothered me a whole lot about what went on in Agile, especially in the first decade from 2000, 2010, is the idea that anybody can do anything, and the concept that you didn't need specialists. So that means that everybody's sort of equally competent, and you need somebody to deal with to go outside, you know, and figure out what customers want and stuff like that. That's just wrong. When I worked in engineering and when I worked in manufacturing, there was a very, very important need for expertise and for experience and for truly understanding certain aspects of the problem that you were trying to solve. And we need to make sure, if you have a job, you want to make sure that your job is challenging your expertise, not saying, oh, we've got 3,000 developers and they're all alike. There was a certain time when everybody said, well, all developers are alike, so we have to have a process that fits everybody in. That's ridiculous. We need to have ways of doing things where expertise is important and can move everything forward. So it's not like everybody needs to be able to do everything and people are interchangeable parts. It's much more like there are levels of skills and areas of expertise, and we need on our teams the right set of expertise for the kinds of problems that we're trying to solve. And your job should not be one that's just plain anybody can do it. Because yeah, then you can just get a boot camp degree and you can do it. You should be looking for something that basically challenges the things that you do well.
Back in the 80s and 90s, there was an assumption foisted off on us by business schools that a good manager can manage anything. That's kind of ridiculous. A good manager cannot manage anything. A good manager is someone that really understands the domain they're managing and can make trade-offs that reflect a deep knowledge of the area that they're trying to make work well. That is something that requires significant expertise. The idea that someone can work in software and not know anything about the technology of software is not any more sensible than the idea that a manager can manage anything if they have, quote, management skills. It's not just people skills.
Actually, a lot of the problems I've seen in software have to do with the people who are making high-level decisions having no feel for the work that they're making decisions about because they've never been there. And I think that that gets us in trouble real fast.
Or when they were there, the world was so different that their expertise doesn't apply anymore.
Are you ready for another question?
I just also wanted to read aloud, but also you can speak. People, I see people writing comments are really valuable, but I'll just read. Chital said, I feel the new cultures of working we are introducing will be teaching great ways of tackling problems, removing blame culture and supporting experimentation and problem solving. The new generation are so lucky. And then Kara said, but it also needs to be recognized that not everyone who has technical experience can be managers. Definitely Google spends a lot of money to keep people as engineers. They want a good engineer. They do not want them in the management track. And I'd be remiss just to point out on the other side, because it's been historically white men building software, and typically women and marginalized groups and people of color are kept out of the traditional pattern or cannot afford the traditional software degree. Boot camps are a great way to bring other skill sets and diversity into the software industry. Also people that will be serving people. So I just have to, especially because we do support at least one boot camp as a conference. So that's specifically aimed at helping Black women find jobs.
Well, yeah, but software was not always a male-dominated area. Software started out as a female-dominated area.
That's what Dave Farley said today too. He
No,
said,
it really, and anybody, if you have not watched the movie Hidden Figures, you need to watch it. I'm just saying. When I started in software, I have a big family and I have a sister 1 year older than me and 1 year younger than me. All three of us had full lifetime careers in software development, all three. And that was, I mean, we're very, very different people, but that was the career you went into. And there was plenty of room for women up until about the early 80s. And most of the places I went, it was about a 50-50 ratio of men to women for years and years and years.
In the early 80s, it became a crappy job because it became a situation where everybody is telling you what to do and you don't have much room for creativity or making a difference with the input that you provide. And as a result, the caliber of people changed. And I think that at the same time, other fields like law and medicine became much more open to females. And the people that did not want to make a difference, that did not want to make choices that impacted other people were attracted more, the introverts, to the software field. And
There you go.
there you go.
Nice theory.
And now we're back to the culture side of tech, aren't we? Yeah, so the next question was, could you expand a little more on, quote, managing throughput, not tasks in the
I would love
context
to.
of optimizing flow? Yeah, it sounds like a well-played
Yeah,
question.
okay,
Yes,
that is it. I could talk forever about that. But so I was being interviewed about 2 weeks ago by somebody who was writing an article for a job website, a blog, and she was saying to me, oh, I'm gonna interview Woody Zoll next. And I said, oh, the no estimates guy. And she said, yeah, now tell me, what is this about estimates? I just talked to Kent Beck, she said. And he said, well, I don't get about estimates. They're just not a thing. And I said, well, let me ask you a question. How many articles do you write a month? And she said, 8. I said, would you ever accept 12? And she said, well, no, of course not. And that's the whole concept. She writes 8 articles a month. She accepts to write 8 articles a month. She knows when whatever she accepts will be done. And if she ever gets slow, and writes only 7, then she's not writing at the pace that she's got commitments for. If she ever gets to the point where it's easy to write 9, she might start accepting 9 articles a month. But she manages her entire job by the fact that she writes about 2 articles a week. Okay? Now, every single software organization can take a look at the number of units of things they put into production in a window of time. I've never met one that can't. In fact, if we're doing a value stream map and I'll talk to somebody and I'll say, so how many of these kinds of things that you do, and it might be a medium-sized task, it might be you could even do this with project-sized things, but typically it's a small or medium-sized thing. I think, how many of those do you actually deploy in a month or a week? And they'll tell me, or they'll be able to make a pretty good estimate. Oh, we do 30 of those every, or we do 20 of those every release, or approximately, or something like that. They know what their throughput rate is, right? And I'll bet you almost everybody here, if you looked at the data, you could determine when software gets put into production, at what rate you release things. And you might have to say, I do 10 small ones and 3 medium-sized ones, or I can do, say, 4 projects in a year or whatever. But you have a history, and you have a good feel for, if it's anything like you've done before, the rate at which your group of people can get that thing done. Now, on that assumption that you can figure out your current output rate, the very first thing you have to do is absolutely stop accepting anything beyond that rate, period. No concept, don't put it on a backlog and say, I can do 10 a month, I accept 10 a month, never more than 10 a month. She can do 8 articles a month, she wouldn't even dream of accepting more than 8 articles a month. You shouldn't even dream of accepting into your organization anything other than the rate that you put out. Makes no sense, okay? The next thing you need to do is to say, well, I accept it here, I put it out there, and it waits in some sort of queue in between here and here. And instead of saying, well, it's in that queue, I need to prioritize, which is a waste of time. Instead, you should say, I've accepted 10, I've got 10 going out. I want to have as small a buffer of stuff waiting to go out as I possibly can. Okay, so nothing gets done while things are sitting between I accept 10 a month and I do 10 a month. So my writer wouldn't bother to accept out maybe more than 6 weeks, because the things that people wanted to write about are going to change in 6 weeks. Similarly, you shouldn't be accepting stuff in beyond, say, maybe, you know, if you do 10 a month, maybe beyond, say, 1 or 2 months, and that's it. You don't need any more stuff. And so if you have a very short queue and you make it first in, first out, and you accept at the rate that you put out, you don't estimate, you don't prioritize. You make a decision when somebody asks you to do something, if you have the capacity to accept it, and your buffer in between is so short that you don't have to decide what to do for second and third, you do it on the order coming in. That's how a flow system works. And you're not worrying about tasks, you're worrying about, am I still doing 8 a month? And am I accepting only 8 a month? And do I have as short a first in, first out queue as I can have so that I get stuff done fast? And you know, you don't get overloaded. You basically have to be prepared to decide as stuff comes at you, yes or no. So your answer for any demand, and there will always be more demand than you can do, is yes, and it'll be done in 6 weeks, which is what our writer will say. Or you say, no, I just don't have time. And I'd love to help you, but I can maybe, you know, see if there's other ways to solve your problem, but I can't accept it. And you might leave some space for emergencies, you know, but fundamentally, you have now, next, and never. Okay? And you're doing this now, this is what you're going to do next, and everything else is never. And if you do that, you are basically moving stuff through that is very current. Okay, it's the stuff that people just asked you to do, and you make the decision on the input flow, and then you manage at a rate. So you don't manage tasks, how many tasks you do. You don't manage how big they are. You don't worry about that. You say, if you actually take a look at it, and when you have things like backlogs, most of the time that something is in your queue, it's in your backlog. If you would actually look at the dates of stuff you put out and the date that they came into you as demand, you would find it's a pretty stable time. And what you want to do is shrink that. And so what you want to do is have very few stuff that's waiting to be done and a way to make that decision right away. And it's just a way better, more comfortable way of managing. It's much nicer to your demand generators, your customers, because they have the answer when they ask you to do something. You can either say, oh, I would so much love to do that, but unfortunately, I just don't have the capacity. And then they know. Or you can say, yes, and it'll be done in 6 weeks, and you will be right. And you can say that right away. And when you get into that thing, life just becomes way easier for you, for your customers, for your teams, for everybody. Make sense? How many do that?
Not many.
Yeah, but don't you envy this young lady who was interviewing us? This young woman was great. She was smart, and but she was free enough to manage her own input queue. And if you can't do that, it's because you're not free to manage your input queue. And you should be.
What about complex systems, if they require long-term planning, if they requires some, I mean, how do you plan multiple iterations?
If people ask you to do something and you don't have the capacity, saying I'll put it on my backlog does them no good, does you no good. It's just a lie. You know your output capacity, you know the rate at which you get stuff done, and that's only as fast as you're going to move.
With a complex system, you can't know beforehand with any amount of planning or thinking or cogitating what's going to work. That's what makes it complex. There are too many unknowns and interactions. So how do you do it? You have to try an experiment. You have to see if this approach or that approach helps you make some progress. Anything that you do in a big batch, a big commitment to a long list of tasks is going to be wrong for most of those tasks. And that is especially true when you have systems that you've never done before, of the kind you've never done before. It's especially true when the complexity of the domain you're working in is very high. Nobody can manage that by detailed, extensive planning. You have to do it by trying a candidate, invest a little bit in it, get feedback, see how that interacts with the environment that you're working in, and adapt. If it works, do a little more, refine it. If it doesn't, start again.
Okay, I was just a bit confused by the idea of not having a backlog. Let's say this writer has 40 articles to write. She doesn't have, or she has a reasonable deadline to write them in 5 months, but she knows that there's 40 articles in the queue. Would this create a backlog, or
No.
how would she manage it?
So she's committed to writing out about 6 weeks. So that'll be 8, 9, 10. So she comes to the time to write the next article. She has a window that's a deadline that's a half a week long. Whatever she writes in those 3 days or 2 days, she may take 1 extra day, but it'll be done. So in a rate-based system, you basically are done when the time is up or close to when the time is up. And so working against hard deadlines as opposed to the task complete and doing best efforts against a deadline is the classic engineering approach. If you look at SpaceX, okay, remember what they were trying to do. They were trying to develop reusable parts for booster rockets. And if you've ever seen the video of the number of times that they crashed booster rockets, like while they were trying to figure out how to land them, they crashed booster rockets every 3 or 4 months because they had a launch every 3 or 4 months. And that launch date, it did not change. When this booster rocket test was going to happen, it was going to happen. And every single team that was heading towards that deadline didn't get to say, oops, I'm not going to be ready. They didn't have that option. They had it's going to happen on this date, and you're going to put the best thing you can to solve the problem. And actually, when you're doing that, you tend in an engineering world to have 2 options or 3 options. One that you know for sure will work by the deadline, and one that would be better if you can get it to work. And then maybe one far out there, it would be cool if it worked. And when the launch date comes, you take whatever option is on the table, either the backup option that you for sure will work, or the one that you've been working that you're pretty sure will work. And that's the thing that you put into the launch or into the test that happens at that 2-month interval or something like that. So when you're doing a large project, you basically divide things into deadlines that are not changed. And all the teams that are contributing, those are what I'll call integration deadlines if multiple teams are working on it. Those deadlines don't change, and the teams bring forward to that deadline their best effort by that deadline. And typically, if you're working in a rate-based system, you can have a little leeway on either side, but essentially you are done when the deadline is there. She doesn't take an extra week to write an article because it's an interesting topic. She writes what she can figure out in 2 days. And that's the concept also in a rate-based system is deadlines happen. They are not changed, or they're not changed by much. And you bring the best efforts that you can for that problem at that time. And if you watch what happened in the pandemic, which we were talking about earlier, when people started releasing stuff, they didn't release the perfect drive up app right away. They released whatever they could release in a week. And then they released something better. And then they released something better. And it's the same concept in a rate-based system. If you have a deadline and you create whatever is going to solve the problem the best you can by that deadline, you've accepted it and you've accepted the deadline.
It's the difference between push and pull. When somebody gives you a list of things to do, they're pushing this list on you. When somebody says, we're going to launch once every 3 months, and your subcomponent had better be ready to contribute to this launch every 3 months with better and better versions, that's pull. The pull is much safer, it's much faster, and it is a lot less waste, because everything you do is focused on getting your part to do what it's supposed to do in the context of all the other evolving parts. And both of those are critical, that by fixed dates, the best you can do is pulled out of your team, your sub-team, to achieve the overall goal of the larger project, the larger product. So it's the same manufacturing that happened in the same revolution that happened in manufacturing in the 80s, which was the transition from an ERP, MRP environment where the computers pushed the work out to the factory floor, to an environment where Kanban cards pulled efforts, determined the scheduling back in the 80s. I don't know if many of you were alive in the 80s, but it was a very, very dramatic, yeah, most of you look pretty young. It was a very dramatic change in the way the whole economy worked. And it's now happening in larger world as well.
Okay, let's go on to the next one. I don't know if it answered your question, but the fact is people have become way too comfortable with the concept of backlogs. It's just a bad concept, really, really bad concept. And I've always felt that way. I remember Tom telling me I was crazy, but I told him I was right. And but the whole idea is that every single software organization out there has more demand than they can handle. And the ones that handle that demand wisely are the ones that don't waste any time figuring out what to do next, because they act aggressively and very fast on the demand as it comes in. And they respond to the demand generator immediately rather than later on. It's a better world for everybody. And backlogs do not belong in our lexicon.
It's probably better if you don't think about demand, but think about opportunity. You're selecting opportunities to pursue rather than complying to some external demand.
And the selection has got to happen in the context of right now, not the context of 6 months ago.
Absolutely. Just to quote from the audience, Andrea's like, I've been frantically taking notes. This is great. Clearly she has an application with clients right now. She's coaching. Alexandra said, +1, now, next, never.
Right.
And Milena said, only once was I lucky enough to have a product owner who understood that and worked hard to hand in hand with me on saying no.
Okay, so what useful purpose is a product owner playing if they overload the team with a backlog? That's just not right.
Absolutely. Amador said, noted, we should run away from endeavors that aim to push and pull as well. I think we can go through one more question and then we should wrap up. But the last question is, dun, dun, dun. Dun, dun, dun. Can we discuss the future of the tester and developer roles, and what is the value of converting those roles into responsibilities? Good question.
So those are two really different questions. And I'll start with the testing one, unless you feel like starting. So I think I like the model that Google developed with testing. And very early on, they developed the concept that developers have responsibility for their code. Now, this is pretty classic engineering approach. All engineers are responsible. You know, if a building falls and you were the engineer that designed the structural elements, you're responsible. So engineers are responsible for the proper working of their code. And testers, really important persons, were there to create tools to help the developers do their job, which is write code that was testable and would for sure work. So they early on had test engineers whose job it was to create builds, to build automation for testing, to work with the development team and help them figure out how to make sure that their code was well tested at all times. And I think testing is critical. I also think that there's a need for exploratory testing that's not automated. And you have to have smart people who understand what that means and how to do it. And that's probably not going to be a developer. But as far as the non-exploratory, the routine testing, that absolutely should be developer responsibility, with the role of testing helping the developers have the automation tools to make sure that they can do it. And then when you come into things like exploratory testing, that's where you need a really smart person that can imagine all the ways that this thing can die. So when I was doing systems for the manufacturing plant, the most senior engineers were the ones that sat back and tried to imagine all the violations of safety, all the crashing mechanisms that could explode the plant, and make sure that there was something in place to cover that. And so you absolutely need testers. When we had, when we switched to a pull system in manufacturing, we had a quality program at the same time. And the big idea there was, it is not the job of quality to test quality, and you sure didn't want to test quality into the product. It was the job of the production part of the plant to make sure that their stuff was always good. And the testing gave, you know, sampling testing and other mechanisms to help make sure that the production people could make sure that their products were good, and they were assistants, but the responsibility for making sure you have good code resides with the people who are writing it. And there's lots of important engineering for people that do testing. And I also think that some of the testing people in Google migrated into the SRE job, because the SRE job is basically a higher level of testing the system. And the SRE job says, the way they do it, if you read their book, is that they say there's an acceptable level of downtime. And if you exceed the acceptable level of downtime, you don't get to do your deploys without a lot of us checking them. But if you stay under your sort of goal of acceptable level of downtime, you can deploy at will. And we'll help you to make sure that you don't exceed it. But we're going to come in and sort of clamp down on you if you start having downtime that's too high. And that's how they sort of balance the SRE role with the development role, so that they all agreed to, if we ever get this bad, then those SREs get to come in and tell us what to do. So they kind of elevated this whole concept of system testing at the same time as they put the SREs in there.
The idea of tester is probably obsolete. There are several kinds of testing. Of course, there's the testing to prove that it does what it's supposed to do. That has been known for decades to be waste. Of course, it should do what it's supposed to do. That's what specification by example, that's what the whole automated testing world that I hope everybody lives in now is all about. prove by construction that it does what it's supposed to do. There's always also the exploratory testing that Mary mentioned, which is to show that the thing that you built does not do what it's not supposed to do. That is the thing that is probably the most valuable remaining role for people that are known as testers. And that, of course, is something that everybody contributes to, but some people are dramatically more skillful at that than others. But then there are the really important tests. And the really important test has nothing to do with software. It has to do with what software you choose to build, what interfaces you choose to provide, what policies you choose to implement. Those are the things that really make or break the success, the impact, the outcomes that you achieve with all of the work you do. And it's really critical that those things be tested, that you make sure that what you are doing is having the impact that you're after, that it's making the behaviors of the people using your software possible and likely.
Yeah, the biggest waste in software development is building something that's useless. And we do way too much of it. So if we're not testing and validating that what we're doing is having the impact that it's supposed to have all the time, that's really a big hole that we're digging ourselves.
Bugs are fairly easy to fix. Wrong choice of what to build is a lot harder and much more important to detect as fast as you can.